Hello students, welcome back in today's session. In today's session we will be seeing exercise 2.2. Small disclaimer. The images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at SATHEE@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Okay. Here's our question. So this question says, if you are having set A with 14 elements, 1, 2, 3 till 14, and we are having relation R defined from A to A and defined as you have to collect all pairs x, y such that 3x minus y must be 0, where x, y both belongs to the set A. So you have to write down its domain, its codomain, and its range set. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. So in question, we are given with set A and there is a relation R from A to A defined as collection of all pairs x, y such that 3x minus y is 0. Then we have to find out its domain, codomain and range. So range, this is our answer. You can all verify that you are getting the correct this answer or not. So let us see that how we are getting the domain set, range set and codomain set. So solution. So the relation R from A to A is given by simply in set builder form collection of all xy pairs such that 3x minus y is 0, where xy both belongs to the set A. Which can be rewritten as, so this condition can be rewritten in this form 3x is equals to y. Now what you have to do is very simple, that just plug x values from the set A here and get your y, the corresponding y value. So if you plug 1 you will get y3, if you plug 2 you will get y6, if you plug 3 you will get y9, and if you plug 4 you will get y as 12. What about other? If you plug x value as 5 then y is 15, but you cannot take that ordered pair in this relation. Why? Because your both elements x and y must be from the set A. Yes, if you plug 5 the y will be 15 and 15 doesn't belongs to the set A. Now the domain of R is simply the first elements of the ordered pairs in the relation. Therefore domain is going to be 1, 2, 3, 4. And the whole set A will be your codomain. And so simply codomain is your this set, complete set A. Clear? And the range is collect all the second elements. Okay? So range simply collection of all the second elements of the ordered pair. So range going to be 3, 6, 9, 12. Okay? This question, define a relation R on natural set, so set of all natural numbers. So relation defined as collection of all xy such that y must be of the form x plus 5, where x belongs to natural number less than 4 and both xy belongs to set of naturals. Then we have to depict this relationship using a roster form and then write domain and its range. Clear? You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So quite simple question. So we are already given that your relation R is from where to where? Natural numbers to natural number, and it is described as you have to collect x comma y such that in what manner x and y related, that y must be of the form x plus 5, where x is a natural number less than 4 and both x y comes from the set of naturals. So just write down the roster form and then find the domain and range set. So quite simple, roster form, domain and range. Clear? Now how we are getting the answer? Quite simple. So first of all, what you have to do is try to find out the x and y's which satisfy the given conditions. So x, natural number less than 4, both x, y must be from natural numbers and satisfying the equation. So we are having 1, 2, 3. These are the only natural numbers less than 4. So x can be 1, 2 or 3. Now if you put x here, you will get y as 6, x2 y7, x3 y8. So these are the only 3 ordered pairs which is in the relation R. Now the domain, quite simple. What you have to do in order to get the domain set, just collect all the first elements from the ordered pairs which is in the relation. So 1, 2, 3. So the domain of the relation R is simply this set 1, 2, 3. Now for range set, collect all the second elements of the ordered pair in the relation. So second pairs, the second elements 6, 7, 8. So range set is simply this set with 3 elements 6, 7, 8. Clear? This question. So set A is given to us with 4 elements 1, 2, 3, 5. Set B with 3 elements 4, 6, 9. And define a relation from A set to B set in this manner that collection of all ordered pair x comma y such that the difference between x and y is odd. Both x belongs to A and y belongs to B. Write this relation R in roster form. Clear? So what you have to do is simply write the roster form. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple question. A, B sets are given to us, are already described in a set builder form. We just have to write it in a roster form. So roster form will look like this. How? Let's see a solution. So first of all, A and B already given to us. Then you have to just collect x, y such that the difference between x and y is odd number, where x belongs to the A set and y belongs to B set. So starting with take x as 1. Now what element you are going to take from the set B that the difference must be your what number? Odd number. So quite simple. So 1 minus 4 is what? Minus 3, which is your odd integer. So what about 2 and 4? Can you take 2 and 4? No. Why? 2 minus 4 is minus 2, which is even integer. But we want odd integer, odd number. Clear? So we cannot take 2 and 4. What about 3, 4? Can we take 3, 4? Yes, because the difference is just minus 1, odd integer. What about 5, 4? Yes, we can take. What about 1, 6? We can take 1, 6. What about 2, 6? No. What about 3, 6? Yes. What about 5, 6? Yes. What about 1, 9? We cannot take because the difference is even integer. So 2, 9, we can take 2, 9. 3, 9, we cannot take 3, 9 as well as 5, 9. So we are getting these 7 ordered pairs in the relation R. Clear? Now this question. So in this figure, we are given with some relationship between P set and Q set. By looking this diagram, this arrow diagram, what we can say is simply that 5 is associated with 3, 6 associated with 4, and 7 associated with 5. Clear? According to this arrow diagram, we have to describe this relation in set builder form and also write this relation in roster form. Clear? And then find out its domain as well as range set. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So quite simple question. As we are already given with an arrow diagram which depicts most of the information, okay, we can easily describe its set builder form and as well as the roster form. So one way is to define the set builder form is like this way. Okay, the domain and range set will be these. Let's see how we are getting these as our answers. So solution. As given this arrow diagram from P set to Q set as 5 related to 3, 6 related to 4, 7 related to 5. So if you observe carefully, we are having P with 3 elements 5, 6, 7, Q with 3 elements 3, 4, 5. Then 5 minus 3 is simply 2. 6 minus 4 is simply 2, and 7 minus 5 is simply what? Your 2. So what you are getting is that you can write the same thing in this form, that y is nothing but equals to x minus 2. Yes, if you subtract 2 from elements of P, you will get Q elements. Clear? So one way is this, to represent this relation in set builder form. Okay. So the same arrow diagram. Now the roster form, very simple. What you are going to do is that you have to collect in roster form. What you have to collect is ordered pairs. How you are going to form your ordered pairs? Quite simple, that 5. So set is from where to where? P to Q set, meaning your pairs must be, or this set relation, this R relation must be subset of P cross Q, meaning the first element of your ordered pair must be from the set P and second element of your pair must be from Q. So we are going to write 5, 3, 6, 4, 7, 5. Not the other way around. Clear? We are not writing 3, 5, 4, 6 and 5, 7 because this relation R is from where to where? From P to Q. From P to Q. These arrows gives you idea that we are taking which set first and which set second. So we are associating this 5 to element 3, not 3 to 5. We are going to left to right. Clear? So we are going to just simply write down all the ordered pairs which are 5, 3, 6, 4, 7, 5. Is it clear? Now domain, quite simple. Just collect all the first elements from the ordered pairs which are in relation R. So 5, 6, 7. And for range, you have to collect all the second elements from the ordered pairs which are in the relation R. So 3, 4, 5. This question. Suppose we are having set A with these 5 elements 1, 2, 3, 4, 6 and R with a relation on A. Relation on A meaning from A to A. Okay. Defined in this manner that collection of all pairs A, B such that A and B both belongs to set A and B must be exactly divisible by A. Exactly divisible by A. So first is to write down its roster form. Second, find out its domain. And third, find out its range. You'll have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. Quite simple question. Relation already described. Okay. You just have to associate A to B in such manner that B must be exactly divisible by A. So your roster form will be like this. Your domain and range and sets will be like these. So how we are getting these as our answers? Let us see. So solution. So set A already given to us 1, 2, 3, 4, 6. Relation, you collect A, B pairs such that A, B both belongs to set A and B is exactly divisible by A. So starting with this, take your A as 1. So what are the numbers which divide this number exactly? So 1 is the only number which divides itself. So 1, 1. Now what about 2? So if you take 2, so what are the numbers which divides this 2 exactly? So 1 and the 2 itself. So we are having 1, 2 and 2, 2. Now 3. So 3 is a what? A prime number. So what are its factors or the number which divide this 3 exactly? So 1 and 3 itself. Okay, so we are having simply 1, 3 and 3, 3. The same goes for other pairs. So 1, 4, 1, 6, 6, 6, 4, 4, 3, 6, 2, 6 and 2, 4. Okay, I hope it is all clear that how we are getting our ordered pairs. Now, in order to get the domain, what you have to do is quite simple. Just collect all the first elements from the ordered pairs in the roster form of R. So we are getting 1, 2, 6, 4, 3. So 1, 2, 6, 4, 3. Now for range, just collect all the second elements. So 1, 2, 3, 4 6. So 1, 2, 3, 4, 6, which is same as the set A. Clear? Now this question. Determine domain and range of the relation R described as, so collection of all ordered pairs x, x plus 5 such that x belongs to the set 0, 1, 2, 3, 4, 5. We will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. Quite simple question. Relation R is already described to you. So you just have to find out its domain and range set. So domain set and range set will be these. How we are getting these as our domain and range? Let us see. So solution. So as described, that collect all your ordered pair x, x plus 5 such that x belongs to this set with elements x can take any value 0, 1, 2, 3, 4, 5. So just substitute x values one by one, 0, 1, 2, 3, 4, 5 in order to get the ordered pairs. So if you substitute x as 0, you will get second position element as 5. Now if you substitute x1, the second element will be of your ordered pair is 6. So 2, 7, 3, 8, 4, 9, 5, 10. Clear? Now domain of R, quite simple. What? You just have to collect all the first elements of the ordered pairs which are in the relation R. So 0, 1, 2, 3, 4, 5. Now for range. For range, it is quite simple that we are having just collect all the second elements. So we are getting what? 5, 6, 7, 8, 9, 10 as our range set. This question. So we are having a relation R described as collection of all ordered pairs x, x cube such that x is a prime number less than 10, and write this set builder form in roster form. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. This question is quite simple. What we are doing is, first of all, the question asks to find out its roster form, which is very easy. The ordered pair are described in this manner that first element is x and second element is the cube of the first element. Simple. And what is my first element? First element is a prime which is less than 10. Clear? So the roster form for this R is going to be this. How we are getting? Let us see the solution. As described, collect all the pairs x, x cube such that x is a prime number less than 10. So prime numbers less than 10, 2, 3, 5 and 7. These are the only 4 prime numbers which are less than 10. Now, if x is 2, then second element will be 2 cube, which is 8. If x is 3, then second element will be 3 cube, which is 27. If x is 5, then 5 cube will be 125. If x is 7, then 7 cube is going to be 343. Clear? This question: set A with 3 elements XYZ, set B with 2 elements 1, 2. Then find out the number of relations from set A to B. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, 2 sets and both sets are finite. Set A having 3 elements, set B having 2 elements. So we can easily find out the number of relation from A to B. So the number of relation going to be possible relation 2 raised to power 6. How we are getting the answer? Let us see. It is already given to us that set A with 3 elements XYZ, set B with 2 elements 1, 2, 3. So first of all, in order to get the relation, you must know about the A cross B Cartesian product. How many elements you are having? So you are having how many pairs? Ordered pairs? 6. So x1, x2, y1, y2, z1, z2. These are the 6 ordered pairs in the Cartesian product of A cross B. Now, we know that the number of subsets of any set having say 6 elements in it, the number of subsets will be simply 2 raised to power 6. So 2 raised to power 6. And we know very well that the possible number of relation is same as the total number of subsets of A cross B. So therefore the number of relation from set A to B is 2 raised to the power 6, which is 4 times 4 times 4, which gives me 64. Okay. Now this question. Let R be the relation on set of integers defined by, so relation is defined by simply collection of all pairs A comma B such that both A and B belongs to the set of integers and this difference A minus B is an integer. Now find the domain as well as the range of the relation R. You will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, relation described from where to where, Z to Z, and described as collection of all pairs A comma B such that A, B both belongs to the set of integers and this difference A minus B is also an integer. Then find the domain and range of the relation R. So domain and range both going to be the set of integers. How? The solution. So as described, you have to collect all the pairs A comma B such that A, B both belongs to a set of integers and A, B is an integer. It is known that the difference of any two integers is always an integer. So the domain of your relation R is simply the complete set of integers. And the range is also the complete set of integers. So this is it from this session. So thank you all for attending this session.